Hello, pre-calculus student. This video is for chapter 5.4, right triangle trigonometry. We are looking at defining trig function, the six trig function that we have defined in 5.2 and 5.3, using another approach that is using right triangles. The way we define it is so that the restriction is these angles in the right triangle would be between 0 degree to 90 degree, excluding 0 to 90, of course. But they are similar to the six trig function that we define using unit circle. So primarily the reason why we do that is we actually can use these functions to solve problems in real life. So in this videos, in this chapter, we will talk about how to define the six trig function using right triangle instead of the unit circle. We also will get new identities, new sets of identity called cofunction identities, and then we'll solve right triangle, um, special right triangles and side length, and also used to solve application problems. So, which is the main goal of defining this new trig function. They're still the same six trig function, except the input angles are between 0 to 90, and they're all positive. Okay, so what is the definition of this right triangle? Does it contradict with whatever that we have before? Actually, no, it is similar to the unit circle definitions. So let's look at how it's defined. Suppose I have a right triangle with an angle T on one of the acute angle. Of course, one angle has to be the right angle. The side facing the right angle is called the hypotenuse. The two sides that is adjacent to the or next to the right angles, they are both shorter than the hypotenuse, are called opposite or adjacent relative to the angle that we talked about, because there are actually two acute angles in a right triangle. So that's how do I define sine t? T is still an angle, and angle is an input. Is opposite over hypotenuse. Cosine is adjacent, the side that's adjacent to the angle over hypotenuse, and tangent is opposite over adjacent. It's the side length. Okay, so if it's sine t, I will look at how this side, which is opposite ratio with the hypotenuse size. And the corresponding reciprocal identities are still the same. Cosecant is the opposite or the reciprocal of hypotenuse, opposite and hypotenuse, so it becomes hypotenuse and opposite. Secant is hypotenuse and adjacent over adjacent, and cotangent is the reciprocal of tangent, so it becomes adjacent over opposite. Okay, so tangent is opposite over adjacent. And the short form of remembering this triangle, this definition is SOHCAHTOA. Sine is O over H, opposite over hypotenuse. Cosine is adjacent over H car. TOA would be tangent is O over A. So SOHCAHTOA actually will give us the three definition of trig functions. The other three, if you remember that they are reciprocal function, then you will know they are opposite of their reciprocal function. So one thing that is very confused a lot of students is which side is the opposite. The opposite side is the one that is opposite to the angle. So for sine and cosine to work, you have to have an input angle. So if you look at your input angle, the one that is far away from it is called the opposite. The one that is actually adjacent or next to the angle T that we talked about is called the adjacent angle, and hypotenuse is the longest side opposite to the right angles. In angles and side pairs, we look at opposite side. Okay. This is the SOHCAHTOA definition again. And how we do SOHCAHTOA. Okay. Now, for example, in case I don't want this angle to be my T, if I want this angle, the one in the top, to be my angle T input, then this side that used to be adjacent will become the opposite. So whether a side is opposite or adjacent really depends on the angle that you talk about. Example 1. So use the right triangle SOHCAHTOA definition to find the value of sine, cosine, and tangent. So I'm going to write it down. So this right triangle has, this is my T, angle T. If this is angle T, I know this is the opposite, this opposite to T. So this is O. 25 is hypotenuse and 24 is next to the angle, so it's adjacent. So sine T would be saw, right? And so H, so O over H. O is opposite to T is 7. H is 25. So that is it. That's the answer. So my input is this angle and my output is 7 over 25. Cosine T would be adjacent, ka, over hypotenuse. Adjacent is A, is 24, and hypotenuse I know is 25. Tangent T is toa, to, so it's opposite over adjacent. Opposite to the angle is 7. Adjacent to the angle is 24. There I have the definition of sine, cosine, and tangent according to this right triangle. According to this triangle. And of course, we use reciprocal identity to do cosecant, which is 1 over sine. Secant is 1 over cosine, and cotan is 1 over tan. Do another triangle. The same. This is T. This is opposite, right? And this is adjacent. And this is hypotenuse. So if I want to do cosine T, that would be the reciprocal of sine T. Sine is saw. So I'm going to just write here. So, ka, to. So sine is a reciprocal of sine. For sine is O over H. So this width has to be H over O. Hypotenuse is 25. Opposite is 7. Okay. And then secant T. Secant T is reciprocal of cosine, which is ka. Ka is A over H. So for this, then if you are reciprocal to it, it's H over A. H is 25 from the diagram or from the triangle. A is 24. And then cotangent T would be, let's look at tangent first, toa. So cotangent would be A over O, the reciprocal of it. Adjacent to angle T is 24, opposite to is 7. So there, that we get the exact value of this trig function. Sometimes we only have two sides. And sometimes our angle is not the one that is on the horizontal here, but kind of like hang in the air here. This is still an angle. So we want to find a six-trig function of A. So let's write this down. Sine A, because it's saw, right? So, ka, to. So sine A is opposite, so it would be this one. A's adjacent is this, and A's longest as hypotenuse is H. Well, I cannot do anything yet because saw means opposite over hypotenuse, but my hypotenuse is blank. So the first thing I'll do when I look at this right triangle is to solve for the hypotenuse. Usually the hypotenuse is C, like side length C. So to solve it, I use Pythagorean theorem. C squared is equal to 4 squared over 12 squared. So they are A, this is A, usually this is C and this is B. So this side is B, oh well, actually that should be, yeah, okay. So C squared would be equal to, we have 4 and 12, so 16, 12 squared plus 144. 16 plus 144 is 144 plus 16, 10, 6, 160. That is C squared. What is C then? C is square root of 160. We know 16 is a good number, so we 16 and 10. That's 4 root 10. Okay, so we get that value. Now we want to find the sixth trig function. So I will write C equal to 4 root 10. And okay, erase this first. Okay, so let's say we do sine t. No, sine A. So we'll say function of A. This is the angle A. Sine A is saw. Go to opposite to sine A, which is 12. Adjacent to sine A was 4 root 10. Okay. We can simplify it as divide by 4, 3 root 10. You can rationalize it, but it's not 100% necessary. Cosine A is ka. Adjacent to A is actually 4. Then hypotenuse is 4 root 10. Oh, the 4 and 4 cancel, 1 root 10. TOA, tangent A, TO, O over A. So relative to AO is 12. Adjacent is 4, so that is equal to 3. And then we have to do the 3 more, right? So cosecant A would equal to the reciprocal of this, so just root over 3, root 10 over 3. Secant A would equal to reciprocal of cosine is root 10. And then cotan A also is reciprocal of tangent is 1/3. So there I define using a right triangle when one of the sides is missing, I would just use c squared equal to a squared plus b squared Pythagorean theorem to do it. So in the next video, we'll talk about special angles. Remember, some of the x and y coordinate are manufactured by the fact that we know this special 30, 60, 90 right triangle or isosceles right triangle. And we will use this to build sine 60, 30, and 45 without using the unit circle.